Welcome. Now we will make a new attempt to actually explore the type of consequences of having two possible climate data sets for running the model. Of course, we know that one is probably much more precise since it is measured at the position where we have the data and the experiment about the soil. But still, we would like to make sure what is the difference and what is the consequence if we, for instance, don't have the data with a meteorological station at the site, but we have only what we could get from this Open Meteo that covers the whole world. Okay, we will remember where we ended. We ended with having created, first of all, one new file called Open Meteo that contains exactly the driving variables for running the model. But we also had our file where we looked to how this data compared to the data that we had from the previous meteorological station, and I call that test forcing. And from that test forcing we actually created a new file called two forcing inputs, and if we click on that we can just quickly remind ourselves that the interesting thing here is that we have in the first display only 5 variables, just like we had before when we looked at only one station. But we have what we call repetition, and we could view either repetition 1 or repetition 2. So now I look to repetition 1 and I can shift to repetition number 2, and we see there are some difference. But if we would like to look to it in more detail, we could go to this detailed description and, for instance, click on temperature and temperature again. And then the later, the green one, is the one that comes from the synoptic station at 2 meters height. The other I don't know exactly, but I assume that it is 2 meters since that's a normal standard. So that's what we had, but now we should try to make use of this to actually assign it to the XML file where we run the model. So I just close this, and then I go to our previous document where we have been already making a test run of the model. That was called PEAT in version 659. So we can click on that, and then we open this 659, and then we have to open this run info. That is the document part where we have the details of what we have done before. And we could of course also look to the history of that and see what we actually did. We have assigned a number of parameters for getting those sensors in the soil, and we have also been looking to the drainage, since we did not have any drainage in this simulation before. But now we should focus more on the meteorological input and see how we can handle that. And if we look here, we see that actually this is now missing because I move that file, and then I select a new PD file. And now I would like to select the file that we called two forcing inputs. And the reason is that we would like to have the option to take any of those. So now that's defined, and if you look here you will see that it looks exactly the same if you just open it here, but then you have this detailed to repetition. Okay, how do we know which one we would like to use? To use this type of file with repetition, we need to adjust a little bit upon the switches again. And then we have first of all one crucial switch in the group of meteorological data, and that is called dynamic indexed input file. That is now off, but this switch needs to be put on. But we cannot do this before we create a copy. It's easy to be eager to start to make modifications, and some modifications you can actually do on a document that is a completed single run. But in most cases we should make a copy and we should work on this document that is for a run to be made. Okay, so now we can visit the switches again, and we can look to the meteorological, and then we see that in the meteorological we have a switch called dynamic indexed input file, and we put that to a multi-PG file. Those PG file that contains repetition could be called multi. But that's just say what type of file we would like to have now. But if we should go further, we should go into a group called additional variables, the same group as where we define those sensors. Here we have something called met file station selection, and now it is said to be the MultiRun number. So it should be the number in the MultiRun that decide which station we should take. So if we are making 100 runs, then we could take 100 stations, but we have only 2. So in this position, I think it's much more simple to use another way to identify the data set you would like to apply. And now I said sequence number, and this sequence number is then a parameter, and this parameter will be located in the group of additional variable. So we go to the parameters, and I find in the additional variable sequence number 1. That's the default value, and we happen to have 2 repetition, 1 or 2. So of course we can test with number 2, and by having set this number it should be possible to run the model. And we do it again with a single run, and it is quick, and it gives us a type of output. And for instance, we could examine here the accumulated precipitation. How do we know that this is actually station number 2 and not station number 1? The only reliable way to do it is of course to compare it with making a simulation also for number 1. So we make one further step, and then I first make a copy, and then I go to the parameter where we have the sequence number, change that back to 1, and with this sequence number 1 instead of 2 I can just make a new single run. So that's it, and it goes fast, and we now have one document 875. I go to the outputs again, and now we can click on this accumulated precipitation, and we got a new chart looking a little bit the same as we had before. But if we would like to compare, I click here on the toolbar for linking documents, and then we see clearly that now we have 3 different simulations. 2 are the blue and the green, and they are on top of each other. And the last is the red, that is, lower. So it looks that we can use the model, and we could take exactly which climate station we would like to have. That's good. But now we don't have been looking to, for instance, what are other necessary settings when we are looking to a meteorological file or a particular site. And then we see there's a group called meteorological data, and this group of meteorological data have also a number of parameters. And I would like to now make an examination of those parameters to see which one we would like to modify. And the only one that was modified compared to the default before was the reference height. That's the height where we have the measurements. That was set to 20 meters, probably because we had a type of forest, but now we have a grassland. So I think it could be better to put it to, for instance, 2 meters. Another very obvious parameter that we need to adjust is this temp, air amplitude, mean and phase. That's the air temperature year function. And we have the air temperature as a dynamic, but if we would like to have an average of the full cause of the temperature variability, then we also define a simple function. So if I click on this now, you will see that it was not easy to see in that, but I make it like this, and then it will be a little bit more clear. This is the expected air temperature at this site, starting with 0 degree in the winter and going up to 20 as a mean value in the summer. That is definitely too high. We are now in the very north, and I could just guess here, we could take it like 4 degrees. That's more realistic. Then we have minus 6 degree in the winter, and we have a shift and maybe 14 degree in the summer. This is not very important to be precise, because it's only used for the lower boundary condition. But still, it should be correct. There's no reason to have it to something that is too warm. So now we have moved from another warmer climate by taking this test file of evaporation. And we have adjusted the temperature, and we have adjusted the reference height. There are also 2 interesting parameters for correcting the precipitation. Normally precipitation is wrong, and then we adjust the precipitation with a factor depending on the temperature. So when we have snow, then the default says that we have a 15% correction of the precipitation. And when we have only rain, then the correction factor is 7%. We can keep on those, but that's interesting when we would like to compare two climate data sets that might be wrong in the precipitation especially. Okay, so that's the meteorological group. The next thing I need to visit now is actually the radiation properties. And on radiation we have one very obvious thing, that is the latitude. And the latitude is actually now also in our file for running the model, but it is not visible, especially not in the one from the local station where we didn't assign any value. But we know that this has a value of 72.95 approximately. And if we put that, we will get a day length during year function, just to demonstrate. And you see, it's obvious. We have complete darkness in the winter, and we have the sun through the whole day in the summer. So we are above the polar circle, and that's nice and interesting. Another thing that we can have some attention to is that we have something called solar time adjust. You remember that the climate data were not very convincing with respect to the timing of the solar time with respect to the hours of the day. The model should normally be so it's follow the sun. It's a model for the nature and not a model for the administrator. So the solar time adjust is how much we might adjust it depending on our time step according to what we have in the input and the actual course of the sun. So this can be put like the time zone some minutes above or below the zero value. But we keep zero here in our first testing. Okay, now we have done change of meteorological conditions, and we are still interesting to see if we will get some type of good results when we are now hopefully coming closer. So I made again a new run, and maybe we could go to the performance. And in the performance, in the validation, we see all those variables that we have here. And then we can see that some are showing a good R square, some are not, some are very far away. But for instance, this temperature sensor at 30 centimeter depth is not too bad. That's the wrong level, but the variability pattern are quite similar. So that's a good sign that we could do something good if we continue to calibrate the model. I would like to give you more details on also strategies for making calibrations, because those calibrations here can of course be done by hand. That is, you click a certain variable and you click on the correspondent measured, and you see the difference. So here you have a simulated soil moisture and you have a measured, and we can see that the model were much above, but there are some similarities in the pattern, so it's still a good hope that we could do something better. Ja. So my ending of this session will be to see if we could do this a little bit more automatic instead of doing it in this individual way. And if we would like to do it automatic, we could select any parameter. For instance, we could select this parameter sequence number for the MET file. And if we right click here, we could put this parameter for a MultiRun simulation. And that is now suggesting that it goes into dimension 1 that has 11 candidates. And we could select a method for how to assign it. And as you see, there are quite a long list of different methods here that can be used. I will take the most simple to start with, a table file. And if I apply that, let's see, we should open a table, and in that table we could type the numbers that we would like to have. So for instance, we could run the model with 1 and 2, 1 and 2. We had not so much to make choice between, since we have only 2 meteorological stations. But let's do it like that, just to have 1. And if we have done so, this parameter will come into the group of MultiRun, and we see that here it is identified as a table method, and we could view those values if we no, we cannot do this yet. We have to we should take one more parameter and one more method, and we can take, for instance, we take something that will be easy to understand, straightforward. The drain level, that's the location of the drain pipes. Providing we don't know this so well or how it is affecting, we can say that it might be something between 1 meter and maybe only minus 0.2. So now I put a minimum of -1, that's meter, and then a maximum of minus 0.2. And I allow this to have a stochastic linear variability for our 11 runs. And now we have this together with those parameters that select one or another climate station. So we can look to many parameters and how they are performing together. We forgot to make the copy. That was why we could not edit it completely, but now I made a copy. Those parameters could be introduced also when you are looking to a completed document. Okay, but now it is, and now I think we can also see that we can look to this table and we recognize the values that we said before, and now we could make a run. But as you see, it's not only make single run, it's also make multiple runs. So let's try that. And it took a little bit longer time, and then it closed. And now we have a completed multi-run, and this will be our, excitement for the next session, because then we can start to explore also how we could evaluate the performance by looking to those type of multi-runs where we have maybe assigned many different parameters in different ways to see the performance, and how useful our model will be also to produce results. So that's all for the moment, and thanks for listening. Bye bye.